All right, in 6.7, we're talking about the areas of triangles and quadrilaterals. Basically, anything with 3 sides or 4 sides, we really want to be able to find the area for. A general quadrilateral, we don't have a formula, but for example, a square, we can figure out how many square units are inside a square. So if you look at this side length's 4, this side length's 4, you get your answer by taking 4 times 4. There are 16 square units. Okay, it's very important to label your answers. On the quizzes that follow this section and on the test, you'll lose points if you don't label your answer. So make sure you do that. Now the area for a square, the formula, a lot of people say it's base times length, length times width, or base times height. Those work. That's actually the formula for a rectangle. Base times height or length times width. Those work for a rectangle. For a square, we're going to be as more specific. We're going to say the side length squared. So for a rectangle, height times the base. So if you're taking notes, it's important to understand that the height, right, just like the height of a triangle, has to be measured at a right angle. For an area of a parallelogram, this is the base, this is the height's measured at a right angle. Notice we can, if I cut this triangle off of the parallelogram, this triangle and this triangle are basically the same. I can move it over here and form a rectangle. So the area for a parallelogram is also the base times the height. So remember, the height's measured at a right angle. Length times width doesn't really, well, width as in this width, but you're not taking that side length. Okay? H is not always a side. Okay, it could be a side if your parallelogram's a rectangle, right? But really, this should work for a rhombus, rectangle, and square. If you think about our last section, right? Parallelograms here. If it works for a parallelogram, why wouldn't it work for anything below it, right? So it would work for a rhombus, and it would also work for a rectangle, and this formula would also work for a square. Okay, you can use base times height. You can do something similar, area of a triangle. It's basically half of a parallelogram. I believe the area of this triangle and that triangle are supposed to be the same. If I combine these into 2 triangles, so I make a parallelogram. So area of a triangle is 1/2 the area of a parallelogram. For a trapezoid, the formula gets a little bit crazier. I'm not sure if I can move anything on here, but if you can imagine taking this triangle, cutting it off, and putting it up on top of here, and taking this little triangle and cutting it off and putting it up on top of there, I would end up with a rectangle. Okay, so the rectangle, area of a rectangle is base times height. But the base, once I cut this off, is not the same length anymore. The base is going to be the length of this red segment, this mid segment. If you guys remember, the mid segment is the average of the bases. So that red line is 1/2 base 1 plus base 2. Bases added together divided by 2. Now the formula for a trapezoid is area equals 1/2 base 1 plus base 2. So that tells me the base, this red sign, we still have to find the height, multiply it by the height. Now the area of a kite, we can find by the diagonals. Okay, basically we have 4 triangles here, or actually you could think of this as 2 triangles, 1 triangle here and 1 triangle here that are congruent to each other. So 1/2 base 1 times the height, multiply that, or excuse me, add that to 1/2, the same base and the height. Excuse me. I'm going to go a different train of thought here. I'm getting myself a little bit confused. You could add the area of the top triangle there, the bottom triangle. But let's just look at, basically, it's a rectangle, but it's going to have half the area, right? This piece and this piece are the same. This piece and this piece are the same. This piece and that piece and this piece and that piece. So if we found the area of the big rectangle, diagonal 1 times the diagonal 2, that's the area of the big triangle, but rectangle, but we have to take half of it, because half of the stuff is not shaded. That's going to be the area of a kite. Now the area of a rhombus, we could use 2 different formulas. The formula for parallelogram, which is just base times height, and there's also the formula for a kite works. So area of 1/2 diagonal 1 times diagonal 2, because kites and rhombuses are basically the same. So either one of these formulas works, and you'll want to, in this case, use this formula, because we know things about our diagonals, and in this one, we're going to want to use base times height. So this one's the easy one. 3 is my height, 2 is my base, so my formula is 3 times 2, which equals 6 units squared. Notice I labeled my answer even if they don't have units. Now if this is 3, and this is 2. How do I know that? Well, the diagonals of a parallelogram bisect each other. So I'm going to say 1/2 diagonal, the vertical diagonal is 4, the horizontal diagonal is 6. This is going to tell me my area. Half of 4 is 2, 2 times 6 is 12 units squared. Okay, here's a question I want you to think about for a second. Which triangle with the same base and the same height has the most area? So, is it this triangle over here? Does this have the most area? This triangle here? Or is it this triangle here, which has the most area? Hopefully you answered the question. They all are the same, right? 1/2 base times height. Doesn't matter where if you take this point and move it anywhere along this line, it's going to have the same area, because your base stayed the same and your height stayed the same. So here that height was one of the sides, here the height's on the inside, here the height's on the outside, but the areas will all be the same. Now, a couple little formulas. Area congruence postulate. Now, a postulate's an accepted statement. If 2 polygons are congruent, then they have the same area, which makes sense, I would hope. Area addition postulate. Area of a region is the sum of the areas of the non-overlapping parts. So if I took like this segment, or this It's not a quadrilateral, it is six-sided, this hexagon. If I want to find the area of this hexagon, I can break it into non-overlapping parts that I can find the area for. So I see a rectangle here. Area of a rectangle is base times height. So the area of that part is 8 times 16, where the area of this part is a trapezoid. So it's 1/2 base 1 plus base 2. So this blue line is going to be 16, just like down there. So 10 plus 16, 26, times the height, 3. And now to get the total area, I have to add these things. So 13 times 3 is 39. And 8 times 16, 8 times 10 is 80, plus 48, 128. Add these together, I get 167 units. Oh, not units, we know the units, so let's call them inches squared. So I broke it into parts, a trapezoid and a rectangle, found the area of both, added them together, and got my answer. Pretty slick technique. One thing though, do not get distracted by extra information. Like, if I said this length was 4, do I have to use that to find the area? No. That might help me find the perimeter, but you don't have to use all the information that you're given. Look at what formula you're using and only take the information from that formula that you need. If you got questions, make sure you write them down so that I can answer them in class.